Hi, so this is the second video, continuing on to slide 11. It says the graph shown in red is y equal to x minus 1 times x plus 3. And the graph shown in blue is y equals to a times x minus 1 times x plus 3. Explain what you know about the value of a. All right, so as we can see, the red graph is facing up. And if you look at the equation, your a value, what do you think that is? There is an a value, even though you don't see anything. You could imagine there is a 1 here. So if I actually wrote in a 1, that means our a value is equal to 1. Now, the graph is opening up, which means our a value is positive. If you recall from the previous slides, going down would mean that the a value has to be negative. So there are two things the a value does. One, it will provide the direction of the graph, which means either up or down. Positive is up, negative is down. And the other thing it does is it will, if you look at the previous slide, you can see that if I move the slider around, as I go to the right, in other words, the values get larger and larger, my a value is getting larger, and what do you notice? The graph is getting steeper. The steeper it gets, we call that a stretch. Now, as I'm going towards lower values, it starts to get wider, and actually, less than 1 and between 0, where we have decimals, is where it gets the widest. We call that a compression. Now, the moment I go below 0, then it starts facing down. So the same thing happens. If it's a number less than 0, between 0 and -1, it's going to be wide. But as I'm getting more and more to the left, meaning the negative numbers are getting further and further away to the left, the graph goes steeper again. So how can we describe that in words? We can say, explain what you know about the a value. The a value will determine the direction of the graph. In other words, up or down. And as well, whether the graph becomes steeper or wider. So we call that a stretch or a compression. So those are the two things the a value does. Okay, let's go on to slide number 12. It says 3 passes. Polynomial challenge number 1. Write the equation of the polynomial in the factored form. So we could see that the graph will pass through the point -8, 0, -1, 0, and then the point 5, 0. So those are all intercepts. We can write the equation as x plus 8. So you can see that the graph has gone through the point 8 here, -8, that is, times x plus 1. Remember, we are looking at opposites, because if I would solve x plus 1, in other words, make it equal to 0 using the zero product property, I would solve for x and I would get an intercept, a 0 at -1. So we can see that we have passed through these 2 points, but then it has one more point to pass through, so times x minus 5. And I have my caps lock on, so let's change that. X minus 5. Okay, and you could see that we have overlapped with the graph. Write the equation of this polynomial. All right, in this case, the graph passes through the point -7, 0. It goes up and comes back down, touches the x-axis, but changes the direction. So this is what we call a bounce. Recall, a bounce means that the degree has to be an even degree. In this case, it's going to be degree 2. So we can write this equation as x plus 7 times x minus 2, and we want to raise that to the second power. All right, here we are going to write the equation of the blue, and we're going to experiment to find the a values. So we can see that the red graph and the blue graph all have the same intercepts, one at -5, 0, one at 0, 0, and one at 6, 0. But we're going to somehow have to fix the a values so it overlaps completely. So if we look at this equation here, we can just rewrite it and then try to determine what our a value is. So x plus 5 times x minus 6. And let's see what this a value could be. So let's slide it. And it looks like it is 0.5. So 0.5, and we have matched the graph. Now, if you notice, the x factor is just, I just realized, is there a TV show like that, X Factor? All right, well, the x on its own is also a factor, and that what would make this whole equation 0 is if this x was equal to 0, and it is right here. Okay, slide number 16, it says write the equation of the blue polynomial. You may need to solve for a using the non-zero point. All right, I think I'm going to stop here and create a new video.